In the last episode of the Great British Bake Off, when they announced that the following episode was going to be about school dinners, I immediately got very nostalgic. I remembered that every Friday we'd have fish and chips followed by jam roly-poly, or as we used to call it, dead man's arm. Charming, I know. This is a delightful, very British school dinner dessert, jam roly-poly, delicious, served with custard. But it's also a really interesting way to learn about the feedback loops that help our AI systems to learn and improve following failure. Welcome to Rose's AI. Look at this jam roly-poly and look at the spirals that we can see with the pastry and the jam. It's particularly delicious with custard, by the way. Now, when AI is learning, it needs to go through millions of iterations, loops, through which it can learn. We call these feedback loops, and they're a bit like the spirals in this jam roly-poly. And so if you think about the rotation as a feedback loop, but that there will be millions of them in an AI system, you can build on what you've already learnt through Yorkshire puddings, where we learnt about the three basic ingredients of machine learning AI, data, algorithms and processing power. The Victoria sandwich, where we looked at the layers in a neural network, a type of algorithm that helps the AI learn from data. We looked at patterns with ginger biscuits and the role of the cookie cutter in defining the shape. And we looked at the slow process of building a sourdough starter in order to ensure that we're building something that can rise. In the same way, we have to be patient and take time to build our AI to learn. Today, we look at feedback loops, and we can see how AI learns from failure, how it repeats and learns again, may fail, learns again, all through these feedback loops. So, join me as we make a delicious jam roly-poly. So let's get started with our suet pastry, very traditional school dinner style suet pastry. In the mixer, I've got 250 grams of self-raising flour, 125 grams of vegetable suet, 25 grams of caster sugar, and I'm going to add, as it mixes, probably about 150 mils of milk. We'll need to see how it goes to see how we get a good mix. Now, I think that's about right, taking a look, and we haven't used quite all of the milk, so you need to judge it because you want the mix to be just loosely holding together. Now, you can think of this as being the starting parameters in our network. So remember when we were talking about Victoria sandwich, and I described it as being like a neural network with different layers, and in each layer, there are millions of tiny little decision points. Now, we have to start those decision points somewhere. We have to give them an initial value. And so we can think about this very loose, not really well-formed dough as being that initial randomized initialization, where we give each of the little tiny decision points a starting value. And so if we look at this, it's a very loose mix, which is exactly what we want. So machine learning terms, this wouldn't be useful for anything yet. It's just randomized, loosely formed dough. And we need a really light touch. Suet pastry needs a really light touch. So I'm not going to knead this a huge amount. I'm just going to knead it very gently to turn it into a formed ball. And then I'm going to pop it in the fridge for half an hour, wrapped in cling film. See how it's done? It looks like we've got to handle it very gently because we want it to stay flexible in the same way as we would with AI. We don't want a rigid network. We want a network that's flexible and able to learn. Now, I'm going to roll this out, and you can see that I've actually put baking paper on the table so that it'll be easier for me to transfer my rolled out roly-poly to its baking environment. Well-floured board. And we want to have a rectangle, well, a square actually, about 25 centimetres by 25 centimetres. And we want to try and keep it even in the same way that we would with our AI. We want even learning. So we've now got a more or less 25 by 25. It's more of a rectangle than a square, but that's absolutely fine. And we've been very gentle in the way that we've handled it. We need to move quite quickly. Unlike our sourdough starter that took 7 days, here we want to move quite quickly because we want a light touch. Raspberries are still plentiful in the shops, and so it's a great time to make a little batch of raspberry jam, and raspberry jam is particularly good in roly-poly. Now, what we want to make sure is that we spread this really evenly. So this is like the training signal in our network. It's the thing that's connecting and helping the network to learn. So we don't want too much to get an over rigid network. We want enough so that the training signal is consistent. So we want to spread it evenly across the roly-poly. Now notice that I'm leaving a border, and that's really important as well. So the border stops the jam from just oozing out and making a bit of a mess, to be frank. So we leave a good border all the way round, and this similar process that we would go through with artificial intelligence. So the border is a bit like regularization with our AI network. We want it to learn because we want it to learn general principles. We don't want it to memorize specific things. So for example, if I was trying to train an AI system to learn how to recognize different pictures of butterflies, for example, and if when I was training it, I corrected every weight on every pixel of the image, what I would end up with is a system that could recognize the particular images that I'd shown it during training, just those images. It wouldn't be able to recognize butterflies more generally. So we need to leave space for learning, so that we get general principles and not memorization. Now, I think that looks pretty good. Quite an even layer of jam, as best as I can. Now comes the really fun bit of trying to roll it up. Now, to start off with, it's really messy, just like our network. It's messy and unstructured and difficult to deal with. But then gradually, as we roll it, we're stuck a bit to the paper here, but we're all right, we begin to get that structure. And each roll connects to the roll before it. And so we end up with a beautiful rolled out roly-poly. What we're going to do with this, we're going to steam it. But think about what's happened here. Each time I've rolled, we've created more structure. And the jam is like the training signal that connects the layers. And what happens is what we call feedback. Each time each layer touches the other, we can connect and feed back from layer in the spiral to layer in the spiral. And this is how we get the feedback in our training of our AI. This is how it learns. Now, sometimes we might have to unroll and start again in order to correct an error. We have to make sure that we roll evenly so that we don't get a lump in the dough that the jam can't get past. So we need a nice even roll. Now what's interesting is that we can't actually see the spiral pattern that we will see when this is cooked and I cut it. And that's a little bit like training the AI network. So we don't see the patterns that it's learnt until we finish the training. We can get feedback about the extent to which the training is producing the kinds of metrics that we want, but it's not the same as knowing what pattern the system can learn. We'll know that when it's cooked. So now that I've done this, and I carefully rolled it up on baking paper because I thought it would be much easier to transfer, I'm going to put it into the paper that I'm going to cook it in. This is greaseproof paper, but I never quite trust the paper to be truly non-stick. So I am now going to transfer my roly-poly to this buttered greaseproof paper, belt and braces, so to speak, to try and make sure that we end up with a roly-poly that doesn't stick. What we want is to fold this up loosely because we're going to steam this and we want it to have room to expand. So first of all, there's the buttered greaseproof paper, and then we cover it in silver foil. And again, we seal it loosely so that it has room to expand. And I'll twist the ends round as well because we're wanting to create an enclosed steam environment. Anybody who remembers roly-poly at school as part of your school lunch knows that roly-poly has to come with custard. And so I quite like to cook a baked custard at the same time as I'm cooking the roly-poly. Bit of power economy there going on. So I've got my baking tray. We fill it up 2/3 with hot water to create a bain-marie that will heat and produce the steam that will steam the roly-poly. But that bain-marie is also a perfect environment for a baked egg custard to go with our lovely jam roly-poly. So this egg custard has 3 eggs and 1 extra egg yolk, 430 ml of full cream milk, 60 grams of sugar, and a little grating of nutmeg over the top. So then I'm going to put my grid over the top that my roly-poly is going to sit on. Oh, got my fingers trapped there. And I'll fill this up 2/3 with hot water, put it in the oven, 180 degrees. Now the roly-poly needs an hour and a half. It's a long cook to steam this dessert. Now the egg custard only needs about 45 to 50 minutes. So you will have to interrupt the cooking of the roly-poly in order to rescue the baked egg custard. Now our roly-poly is steaming away in the oven at 180 degrees centigrade with its egg custard underneath. So what's happening in the oven? Well, it's in a nice, consistent, controlled environment. It's rolled up, it's encased in baking paper and foil, sealed up, but loosely, and placed over that tray of water to get that steam. It's a controlled environment to bring about a consistent transformation, exactly as we want when we're training our AI systems. So in the oven, what's happening is that heat will melt the suet to create layers in the pastry. The jam will heat and bubble up and integrate the dough in each of the spirals as we go round. Now each layer in that spiral is affected by and affects the layer that it touches as it goes round. And this is true in our AI networks as well. The layers and the feedback loops impact on each other. And that's important. Now sometimes things go wrong. When we're training our AI networks, there are errors, and that's how it learns. It learns from making mistakes. And when mistakes happen, it has to work its way back through the spiral, through the layers, has to identify the size of the error. It has to look and see which values contributed to that error and to what extent, and then to correct the different values in the different layers and try again. So there's a lot of failure involved in learning and training for our AI systems, and that failure is really important. Now, other things that can go wrong, and will be interesting to see when we take our roly-poly out of the oven, whether we've got a nice even spiral or not. Maybe I've rolled it too tight and it's a bit compressed. Now, the equivalent of that in our AI networks would be that we've been too tight in our training and we end up with a network that's very specialized in what it can do. So in my butterfly example from earlier, it would be a network that could only perhaps recognize one type of butterfly. Alternatively, if my roly-poly falls apart because I didn't roll it tightly enough, I will have, in AI equivalent terms, a network that doesn't learn, that isn't learning, because it's not been in enough touch, there's not been enough contact in those feedback loops. And this is what we describe as overfitting when it's too tight and underfitting when it's not tight enough. So there are various different things that can go wrong. But what's really important is that we need our systems to fail in order to learn. And it's similar for us, isn't it? Often we learn the most when we make mistakes, that constructive failure. I'm really looking forward to seeing how good the roly-poly is when we get it out of the oven in a very short time. Just taken this out of the oven, probably a lot of steam will come out. Oh yeah, perfect, look at that. There we have our lovely jam roly-poly. I'm gonna take it out of its wrapping, put it on a nice cloth, and let's cut into it and see what we've got. Cut and see. Oh yes, look at those beautiful loops. The spiral shape of the jam and the nice fluffy pastry. But actually, if we look, we can see there's a little bit of a lump in the dough on this side. Now, this is a little bit like what can happen with AI. We can sometimes get stuck in a loop, keep getting the wrong answer, and we have to then think about unwrapping. We call that getting stuck in a lump, as it were, a local minima. And we have to make an adjustment to the learning rate of the network to correct for that lump so that it doesn't get stuck and keep giving us the wrong answer. If you remember when we talked about the sourdough starter, we had to throw away half the starter on several occasions as we're building it, and we do continue to throw away part of the starter in order to stop it getting too rigid. This is slightly different in that we have to roll back to stop that in the moment problem. But what's also interesting about this is we've got this lovely spiral pattern in our roly-poly. Now, we didn't directly program that in. It emerged through the process of the rolling and then the steaming of the pudding. And in the same way, when we're training an AI system, for example, to do facial recognition, we don't write a description of a nose and say, this is what a nose is like, and train it in that way. We expose it to multiple millions, in fact, of examples of features. And over time, it learns the pattern of those features so that it can then recognize those features. Now, I'm going to cut myself a slice of this delicious looking roly-poly, and I've got some nice custard there to go with it, and have a nice cup of tea. This is the favourite part of the episode for me, where I get to taste the jam roly-poly and the custard. I hope you've enjoyed this episode, and as always, there are 3 things to take away from this episode. 3 learning points about AI through baking. Firstly, iteration creates improvements. We need to make multiple passes through data with our AI system so that they can learn. It takes millions of iterations. Second, feedback loops, remember the spirals in the jam roly-poly, shape the outcomes. When things go wrong, when there's an error as we're training, that's a good thing. We can roll back, we can retry, we can adjust, we learn, because we want a system that has general principles, not memorisation. And the third point is that patterns emerge just as this spiral in the roly-poly emerged through the way that we rolled the dough with the jam. And sometimes we see unanticipated capabilities emerging from our AI systems through these feedback loops. And remember, in AI, as in puddings, the magic isn't in a single roll, it's in the way each roll builds on the last one.